Newton's formula for velocity of sound. According to Newton, he basically modified what we got in the previous case. So he made it more particular about the expression. So he said that when we speak, or the sound, when we produce sound propagation, when it moves through a medium, the sound propagation is an isothermal change. Now we have learned this in chemistry also. What is an isothermal change? An isothermal change is a one in which temperature remains constant. So if you take an ideal gas equation, our equation will be PV equal to nRT, right? Where N is the number of moles, R is the real gas constant, and T is the temperature. N is already constant for a given system, R is real gas constant, and if temperature also becomes constant, then everything on the right hand side will become constant, and we get an equation which we call it as equation of isothermal change, PV equal to constant. PV equal to constant is an equation of isothermal change. Isothermal change. According to Newton, sound wave propagation is an isothermal change. So he took this equation to simplify and rewrite the expression we found in the previous case for a general formula for a longitudinal wave velocity. Okay, so PV equal to constant. If I differentiate this, if the volume is, let's say, expanding, or if the volume is changing, then we can differentiate this equation on the left hand side and the right hand side with respect to volume. So it will be written, you can change the pressure also. So in that case, you will differentiate with respect to pressure. So here we are changing with respect to volume. So it will be d by dv into P dot V will be equals to d by dv of a constant. Now derivative of a constant from maths is 0. Differentiation of any constant is 0. So right hand side we left with 0. While left hand side, we know that pressure and volume, they are dependent on each other. Boyle's law is there. So we will have a multiplication rule. We will apply it. P dv by dv plus V dp by dv. This is multiplication rule in differentiation or derivatives. Now dv by dv is nothing but 1. So for discrete changes, I am writing it as b, and dp I am writing it as delta p upon delta v is equals to 0. Let me repeat again. dv by dv is 1, and dp I have written it as delta p, and dv I have written it as delta v. Let's move further. Multiply the whole equation with delta v. It will be p delta v plus v delta p is equals to 0. I multiplied the whole equation with delta v. Now from this expression, let's take everything on the other side and find our pressure. So pressure is nothing but taking v delta p, it will be minus v delta p on the right hand side, and delta v will go in the denominator, so it will be this expression. Recall, this is our expression for bulk modulus. So this is nothing but bulk modulus, so hence pressure is nothing but bulk modulus in case of isothermal change. And we can modify the expression we got in the previous case as V, which was previously root under B by rho, where B was the bulk modulus. Now it is nothing but V is equals to root under pressure upon density. Now this is your new expression given by Newton.